Woohoo! Factoring day 3. What are we going to do? Oh, we're going to do all kinds of amazing GCF factoring today. But first, let's have some bell work problems for review. Will you please factor this? X to the third minus 16x. Factor completely. Pause the video, give it a try. Okay, welcome back. Did you GCF factor first? And then look back again and say, hey, that's a difference of squares. There we go. Okay, next one. Try this. 3x to the third plus x squared plus 15x plus 5. Please factor that completely. Okay, welcome back. So, for terms, we do factoring by grouping. Take out an x squared. I have 3x plus 1, right? X squared divided by x squared is not 0. It's 1. And then here, I can take out a positive 5. 15x divided by 5 is 3x. 5 divided by 5 is not 0. It is 1. And so then, I can GCF these out, leaving me with this and this. Great. Is this a difference of squares? Should I go further? No, that's a sum of squares. We can't factor a sum of squares without imaginary numbers. So moving on. All right, how about this one? 2x to the third minus 16. Please factor. Did you start with GCF factoring first and come up with x to the third minus 8? Did you then say, two terms? Why, that's not a difference of squares, but it is a difference of cubes. It's x being cubed and 2 being cubed. So x minus 2, this one squared, this one squared, and the middle term is this times this, change the sign. Are we done? Nuh-uh, don't lose that original GCF. Okay? And how about one more? 8x squared minus 14x plus 3. Okay. Pause the video, give this one a try. All right, welcome back. Did you have 4x and 2x, 3 and 1, both with minuses? That's our factored form. I did it with guess and check, but I can certainly show you by saying I want the factors of 24 that add up to negative 14. 1 times 24, no. Oh, wait, since they have to add up to negative, both of these have to be negative. 2, negative 2, and negative 12. Oh, there it is. So then I replace the negative 14x squared with negative 2x squared minus 12x plus 3. I group in pairs. Don't forget to catch this sign inside that parenthesis, or you will get the problem wrong. Here I can factor out a 2x, leaving me 4x minus 1. 2x divided by 2x is 1, not 0. And here I'm going to factor out a negative 3, leaving me 4x minus 1. Positive 3 divided by negative 3 is negative 1. These are the same, so I can pull that out. And now I've got left over a 2x minus 3. So by whatever method you're using to factor a trinomial, you need to be comfortable with that. We are not gonna say goodbye to factoring trinomials for a long time in math. Okay, so now, here's what we're doing today. We're doing some more practice with GCF factoring. And I know you say, but we've done GCF factoring. Yes, yes you have. However, 2x plus 1 squared, 3x minus 4 squared, plus 2 2x plus 1 to 3x minus 4 cubed. That's our problem today. See, the reason we're doing this is because students who go on to calculus do some calculus, and then this is the result of having done some calculus. And now what those students are asked to do is find when this is equal to 0. And that's kind of impossible right now. So we know, though, if we have something in factored form, we could just set the factors equal to 0. And so that's why we really are doing this, so that kids in calculus will know how to go from their calculus to the x-intercepts they're looking for. So for us, we're just focused on the GCF factor, and that's great. What do you see here? Well, I see two terms. Are there any factors in common on those two terms? Well, this has 3's and this does not have 3's. This has 2's and this does not have 2's. So those are not common factors. I don't have to worry about those. I do want to look for common factors, like 2x plus 1. And remember, I always take out the smallest power. So I'm going to take out 2x plus 1 to the first. And then I also notice that we have 3x minus 4's in both of them, but now the smallest power is 2. So I'm going to take out a 3x minus 4 squared. Now, what about the stuff that's left over? After I factored those things out, what's left over? Well, this 3 is still there, this 3 is still there, so I have a 9. I took out 2x plus 1 to the first, but we had 2x plus 1 squared, so I still have a 2x plus 1. We took out 3x minus 4 squared, so that's gone. Now we have our plus sign. Then these 2's are still there, so 2 times 2 is 4. We took out a 2x plus 1 to the first, so that's gone. And here with 3x minus 4, we took out 3x minus 4 squared from our 3x minus 4 to the third, so we still have a 3x minus 4. Okay, so this stuff is pretty much set, but in here, I have to distribute and combine like terms. So I'm going to have 18x plus 9 plus 12x minus 16, which is 30x minus 7, times 3x minus 4 squared times 2x plus 1. Now, look here. Is there any more factoring we can do? No. So we're done. And those going on to calculus, in calculus, you'd set each of these factors equal to 0 next. So this GCF factoring skill, hugely important for kids moving on to calculus. Okay, so that's a reminder of what our GCF factoring looks like. And now guess what? Now I have 6 problems for you to practice, maybe 7. All right, so here you go. 2, 3x plus 1, 2x plus 5 cubed times 3 plus 3, 2x plus 5 squared times 2, 3x plus 1 squared. All right, you know what you need to do. You need to factor this. So please, GCF factor away. Pause the video, come back when you're done. Let's check our answers. Okay, so I noticed 2 times 3 is 6, and 2 times 3 is 6, so I'm going to pull out a 6. And then I see a 3x plus 1 and a 3x plus 1. I take out the smaller power. And I see a 2x plus 5 and a 2x plus 5, but I take out the smaller power. And then I play the what's left over game. I took out the 2 and the 3. I took out the 3x plus 1. And I took out 2x plus 5 squared from 2x plus 5 to the third, which leaves me 2x plus 5. Now we have our plus sign. And then what about from the second term? Well, 2 times 3 is 6, and we took that out. We took out 2x plus 5 squared, so that's gone too. And we took out one of these 3x plus 1's, so we still have a 3x plus 1 left over. Okay, so I'm going to have 5x plus 6 times 2x plus 5 squared times 3x plus 1 times 6. Hot dog! See, these problems aren't so hard. All right, how about this one? 4, 3x plus 2 to the third times 3 times 2x minus 1 to the third minus 3x plus 2 to the fourth times 3 times 2x minus 1 squared times 2, all over 2x minus 1 to the third squared. Again, where does this come from? It comes from doing something in calculus. We did our calculus, and this is what showed up. Now we need to use our pre-cal to simplify this expression, because we have to set this equal to 0 and solve for x soon. All right, so what do we need to do? We need to GCF factor up top. You might want to tidy up the bottom too, and then maybe when you're done, there will be some canceling on top and bottom. Pause the video, give it a try, come back when you're done. Okay, so here's what I notice. I can take a 3 out of each, and I can take a 2 out of each. So I've got 6. 3x plus 2 to the third, 3x plus 2 to the fourth. I'm taking 3x plus 2 to the third out. And 2x minus 1 to the third, 2x minus 1 to the second. I'm taking out 2x minus 1 to the second. So now let's play the what's left over game. I took out all of these and this. I took out a 2 from here, but I still have a 2. And 2x minus 1 squared from 2x minus 1 to the third, I still have a 2x minus 1. Now I come to my minus sign, and we took out 3 of these, so we still have a 3x plus 2. We took out the 3 and the 2, and we took out the 2x minus 1 to the second power. So this is all that's left over. I'm going to have 4x minus 3x is x, minus 2 is minus 4. All right, so now the problem looks like and that. And don't forget, we've got this denominator. When I raise a power to a power, what do? I multiply 2x minus 1 to the sixth. Now, is there anything else we can do? Well, look, it's this times this times this times this over this. I can cancel. There's no pluses or minuses between those terms. So these two can factor with 2 of those. And so my final answer would be 6, 3x plus 2, x minus 4, all over 2x minus 1 to the fourth. Ta-da! All right. I hope you're starting to feel comfortable with this. No, huh? Well, let's have another. 3x minus 4 squared times 3 times 2x plus 1 squared times 2 minus 2x plus 1 cubed, that's a cubed, times 2 times 3x minus 4 times one more 3, all over 3x minus 4 squared squared. No, really, it comes from doing a calculus thing. There we go. It's not a hard calculus thing either. It's a really easy calculus thing. The hardest part about these is doing the GCF factoring, not the calculus. Okay, so try factoring this. Remember, I want you to combine like terms where appropriate, and I want you to simplify as much as possible. Pause the video, give it a try. Okay, welcome back. I see a 2 and a 3, a 2 and a 3, so again, I can pull out a 6. No, you won't always pull out a 6. It's just in these problems, I wrote them, they come out with a 6. All right, what else do I notice? I notice a 3x minus 4. The smallest power is 1. And then I see the 2x plus 1. And the smallest power between 2 and 3 is 2. So what's left over? Well, I took out 2 of those, so I still have 1 left. And I took out the 2 and the 3. And the 2x plus 1 squared, that went away as well. So now I'm up to this minus sign. Don't forget the minus sign. We took out 2 of these, as I recall, so we still have 1 of those left. We took out the 2 and the 3 for this 6, and we took out the 3x minus 4 to the first. So that's all that's left over. Now on the bottom, when I raise a power to a power, I multiply them. So I'm going to have 3x minus 4 to the fourth. Here, don't forget, you need to distribute that negative. A lot of people get this far and then do this. 3x minus 4 minus 2x plus 1. Wah, wah. Problem's wrong, because they're supposed to distribute this negative to this positive. This is supposed to be a minus, and so they should end up with x minus 5. Okay, so that's going to go away and become x minus 5. Please be careful with your distributing. And then here, I notice that this can cancel one of these. So my final answer is 6, 2x plus 1 squared, x minus 5, all over 3x minus 4 to the third. Yay! We're done. All right, I got 3 more in mind. And then a closure activity. Okay, so how about negative 2, 2x plus 1 to the negative 3 times 2, 3x plus 2 to the third plus 3, 3x plus 2 squared times 3 times 2x plus 1 to the negative 2. All right, now don't be scared about negative exponents. But remember, just like 1 is smaller than 2, negative 1 is smaller than 1, negative 3 is smaller than negative 2. The more negative, the smaller it is, okay? And remember, when we factor here, we always take the smallest power. Always take the smallest power. So what is that going to look like? Well, let's do this one together. I got 4 here and 9 here, so I can't pull out a coefficient. But I have 2x plus 1 to the minus 3 and 2x plus 1 to the minus 2. So I'm going to pull out 2x plus 1 to the minus 3 because that's the smallest power. If you don't take the smallest power out, you're going to get in trouble. You're going to get to a place where you're stuck and you can't factor it and you're all sad. And don't be sad, just remember that negative 3 is smaller than negative 2 and take that one out. Okay, and what else? 3x plus 2 to the third, 3x plus 2 to the second. I got 3x plus 2 to the second. Now, about playing the what's left over game. I know I have negative 4. I know I still have one of these 3x plus 2's, but what about this? Okay, so let's go back in time for a moment. 2x plus 1 to the negative 3, and I'm factoring or dividing by 2x plus 1 to the negative 3. Well, what's that going to equal? Thing over itself. That's 1. So this is times 1, right? Because that was this part. Now I come to my plus sign, and what's left over here? Well, that 9 is still there because we didn't take out any constants. So I've got 9. Now, we took out 3x plus 2 squared. Here's a 3x plus 2, so that's gone. And what about here? 2x plus 1 to the minus 2 divided by 2x plus 1 to the minus 3. Do you remember me saying at the beginning of the Algebra Basics unit that what I want to do is not flip these? What I want to do is just say, okay, that's 2x plus 1 to the minus 2 minus, right, because when I'm dividing and the bases are the same, I subtract the exponents. So I have minus 2 minus a minus 3. That's going to be minus 2 plus 3, or 1. So we're just left with a 2x plus 1, okay? I'm going to be very surprised, or it's most of the time, what's left over, everything is to the first power. Not always, but much of the time. So, did you catch that? When I factored out a 2x to the minus 3, that's the same as dividing by to the minus 3. And what was it that I was dividing? I was dividing 2x plus 1 to the minus 2. When the bases are the same and I'm dividing, I can subtract the exponents. 2x plus 1 minus 2 minus a minus 3. I'm subtracting that negative 3 down there. and that's what gave me to the first power. Okay, so let's tidy this up. We're going to have 2x plus 1 to the negative 3, 3x plus 2 squared, and then in here, minus 12x minus 8 plus 18x plus 9. So let's combine some like terms. We'll get 6x plus 1 times 3x plus 2 squared times 2x plus 1 to the negative 3. Now, if you want to flip this down on the bottom and have a denominator, that's great. But those of you moving on to calculus, yeah, it's fine just to leave it like this. I prefer it. I think your life will be easier if you just set each factor equal to 0. Okay? All right. So, negative exponents. I think that needs some more practice. 2x plus 1 times 2 times 3x plus 2 to the negative 3 plus 2x plus 2 to the negative 4, negative 2, 2x plus 1 squared. All right, you know the drill. Press pause, factor this thing. I want to see it factored. Yes, this is going to show up on the test. I promise. It's not just for calculus students anymore. Okay. Let's take a look at our two terms here. I can take a 2 out of both of them. I can take, that's a 3x plus 2, by the way. I can take 2x plus 1 to the first out. Now, what about here? Oh, yeah, this doesn't have a 3, but this has a 3, so I can't do anything with that. With the 3x minus 2 to the negative 3, or 3x plus 2 to the negative 4, which one do I take out? I always take out the smallest power. What's smaller, negative 3 or negative 4? Negative 4 is smaller. So now let's play the what's left over game. I took out this 2, I took out this 2x plus 1, this is still there. And I took out 3x plus 2 to the negative, 3x plus 2 to the negative 4th from 3x plus 2 to the negative 3rd. So 3x plus 2 to the negative 3rd over 3x plus 2 to the negative 4th. What's the rule when I'm dividing and the bases are the same? I subtract the exponents. So it's going to be 3x plus 2 minus 3, subtract this exponent, minus 4. Minus a minus is plus, negative 3 plus 4 is going to be 1. So I just have 3x plus 2 to the 1. Really? It's that easy. It's not that big a deal. Just subtract the exponents. I've been telling you to do it for a week now. All right, now we have our plus sign. And then this 3 is still there. In fact, instead of a plus sign, I'm going to have negative 3. And then we took out all of that, and we took out one of these. So we still have a 2x plus 1 here. All right, so what do we got? We've got 6x plus 4 minus 6x minus 3. So many people forget to distribute the negative 3 to the 1. The 6x's cancel, 4 minus 3 is 1. So I just have 1 times this stuff. So that's my answer, 2x plus 1 to the 3x plus 2 to the negative 4. You know, if that negative exponent bothers you, fine, move it to the bottom, turn it into a positive. Either one of those will be fine, okay? But it's all that stuff times what we got left over here, which was just 1, okay? Okay, so what can you do with this one? Kind of lost. I think it's this. Negative 2, 2x plus 1 to the negative 3, 2, 3x plus 2 to the negative 3, plus 2x plus 1 to the negative 2 times negative 3 times 3x plus 2 to the negative 4 times 3. Hot dog. That's not plus 4, that's minus 4 power. All right, Pause the video. GCF factor away. All right, welcome back. So I see a negative with each of these. So I'm going to take out a negative. 2 times 2 is 4, 3 times 3 is 9. I can't do anything with those. I've got 2x plus 1 to the negative 2 and 2x plus 1 to the negative 3. I know I'm supposed to take out the smaller power. Okay, and then I have 3x plus 2 to the negative 4 and 3x plus 2 to the negative 3. I'm taking out the smaller power. Now what's left over? Well, I took out the negative. I still have 2 times 2. And here, we factored out from 2x plus 1 to the negative 3, we factored out a 2x plus 1 to the negative 3. So that's gone. But what about here? What about 3x plus 2 to the negative 3, and I'm factoring out 3x plus 2 to the negative 4? Well, we know we're supposed to subtract those exponents. So we have minus 3 minus a minus 4. That's minus 3 plus 4, which is 1. So we've got 3x plus 2 to the 1. Now we have our plus sign. Now what about here? I took out the negative. I had 3x plus 2 to the negative 4, but I factored all of that out, so that's gone. So right now I just have the 9. Now what about here? We have 2x plus 1 to the negative 2, and we factored out 2x plus 1 to the negative 3. So 2x plus 1 to the negative 2 divided by 2x plus 1 to the negative 3. Why do I know the negative 3 goes on the bottom? Because that's the thing I factored out, and factoring is this dividing. When the bases are the same and I'm dividing, what do I do with the exponents? That's right, I subtract them. 2x plus 1 to the minus 2 minus a minus 3 is just going to be 2x plus 1 to the first. Remember what I said a few minutes ago about how when we do this, this is almost always going to end up being positive 1. Okay, so you don't have to really stress about it. All right, combining like terms, I've got 6x plus 4 plus 18x plus 9, or 24x plus 13 times 3x plus 2 to the negative 4th times 2x plus 1 to the negative 3rd, and don't forget the minus in front. If you left that minus off in front, I'd have to mark the problem wrong. That would be a very sad face. So, keep track of things, okay? All right, so at this point, I like to think you can do this stuff for assignment number 18. And when I look at the assignment calendar, I notice that assignment number 18 is, in fact, a bookwork assignment on 2 different pages. And notice how it says PA 37. Well, A, that's not the same as page 37. This is saying go to the appendix. You're going to the appendix in the back of the book after chapter 10 as an appendix, and you're looking on page A37 of the appendix, okay? Okay, so please make sure you give these problems a try. I would expect to see this kind of thing on a CFA and definitely on a test. All right, let me know if you have any questions or need any help. Use the group me, and I'll see you either in the next video